In this session we'll complete 50% of chapter. I think it's the number is 10. Yeah, sorry. Yeah, so yeah, for some reason I thought it's 10, but yeah, but we'll discuss about inheritance uh, and a couple of other topics from Zybook. So the topics that we cover here will be directly from Zybooks, but the content examples might differ because you anyhow will do the Zybook activities and everything. So I don't want to cover that in the lecture. So, but the contents will be the same. Uh, Yeah, so we're gonna discuss about first topic is classes and objects. Some of the topics you might already know from programming one, but we'll just refresh. Some of the topics will be new, obviously. Uh, and so classes, objects. So a class is a blueprint. It's like a blueprint what fields and methods where fields and methods exist, and an object is a real thing made from that blueprint, and the fields, constructors, methods. Basically, fields hold data, constructors build objects, and methods do actions or written information. We'll get a better understanding when we look at the example, which we'll do later. And we have access modifiers. Access modifiers, we have public, private, protected. So public, anyone can see it. Private, only the class itself can see it. Protected is basically subclasses, and same package classes can see it. So subclasses and basically same package classes can only see the protected fields. And we also have a package private, which is a there's no keyword, which is basically visible only inside the same package. And we have array and array list. So the difference between arrays and array list is arrays have fixed size, array list grows or shrinks, and has helpful methods like add and the enhanced for loop, uh, and we have method overloading and method overriding. So overloading is basically same name but different parameter list in the same class. Overriding, it's a overriding is a child class which replaces a parent method with the same signature, which will be covered more in later. Now we'll look at an example. The example is a kind of big example, but it's simple. Let me look. Yeah, I've already prepared the example to save time. Since we'll be using a big examples, I don't want to waste the time to manually type everything now. I'm using an online editor. You can use an IDE or online editor to practice or to study. But Zybooks, it's different. Zybooks is basically an online editor. It's pretty much simple to this editor. So yeah, let's go through the code here. So here we have in this code we have arrays, array list, overloading combined into one code. That's why it's big one. So here we'll go line by line. We have import Java. The first line, we bring in here the array list, so we can use a resizable list. And we have class, as you know, which defines the blueprint of a person. The class name is person. And then we have private string name, private int age, which are fields are private, so only person controls access, which is person class. And we have public person string name int age, which we have brackets. So this is a constructor, sets required data when we create a person, and this dot name is equal to name, this dot age is equal to age, assigns constructor parameters into fields of this object. And next we have public string get name and get age. So these are getters, which getters expose field values safely. And we have public string greet, which is the first version of greet, which is with no parameters. And here next we have we overloaded greet with same name, different parameter list. And this is basically overloading. And we have main method here, which is the entry point that holds main. In the main we have person p1, person p2, which person p1 creates an object using the constructor, and person p2, it's just another object. And we have arrays here. Can you see it? Yeah. Like, is it visible clearly? Yes. Okay. Can actually. Okay. Yeah, that's better. So array. This is an array with a fixed length of 2. These store objects in the array, and we have a for loop, which is a standard index loop over an array. And we have a print statement, which calls the no argument greet on each element. Next we have ArrayList. Let me turn that off. Okay. So next we have ArrayList. As I mentioned, ArrayList is resizable. Here the resizable list with the generic type person, and people add p1, p2, and new person. We're adding a new person here. So the array list can grow here. So that's what I mentioned. The array list can grow and also can shrink. And lastly, we have again for loop, which is enhanced for loop with a clearer iteration. And print statement, which calls the overloaded version with the parameter. So what to notice here is arrays are fixed size, array list is flexible, overloading lives in the same class and is decided at compile time based on parameter list. Let's see what it means. Yeah, it's just printing all the print statements that we put for overloading, array list, everything. So next is inheritance. So inheritance, in simple words, is a, which is a relationship. For example, an employee is a person, so that's inheritance. In simple words, that's what inheritance mean. we have I think we have extends keyword, which is like for example class employee extends person. And we have Java has a single inheritance for classes, one direct parent. And we have fields methods are inherited, so constructors are not inherited, but fields and methods can be inherited. And we have a constructor chaining, so a child constructor calls parent constructor with the super keyword. And we have UML. Thing. Yeah, this is so employee here child parent, but the open triangle arrow points to the parent. Let's look into a code to get a better understanding. So here let's discuss this line by line. So again, class person, which is a parent class, which is basically a super class. Protected string name and protected int id. Using protected only visibility for visibility demo. Normally key fields private and use getters. And we have public person, this line, which is a parent constructor, initializes common state. And we have a method that child classes can override. And this is a child class, which is a subclass that is a person. Private double, this is a new field that only employee has. And we have a public which is this is a child constructor. We have super name id, which is this must be a first statement. It runs the parent constructor to build to build the person part. And this dot hourly rate is equal to hourly rate. This is then here we set the child's own field. And this is basically the behavior specific to employee. And override, this part it's basically overrides the parent's info, same name, parameters, and compatible to return type. And this is the entry point. And we are building an employee and printing it. This calls overrided method prints employee, not the person. And this print statement uses child only behavior. And what else? And person p is equal to e. It's basically it's upcasting, treats the employee as a person reference. And again print still prints the employee version because of the dynamic dispatch at runtime. So here what to notice here is constructors don't get inherited. You must chain up with super keyword. And overriding chooses the method at runtime based on the real object and not the reference type. Next we have derived classes. So private, protected, package private, public, these are derived classes. As I mentioned, private is basically only the class itself can see it. Subclasses cannot see it directly. Protected is subclasses can see it, so can classes in the same package. And we also have a package private, which is it's visible to any class in the same package, but not to the subclasses in a different package. Public, it's visible anywhere. So we have a cross package rule to remember. So if a subclass uh, lives in a different package, it can see protected members of its parent. It cannot see package private members. And we have unrelated classes. Unrelated classes in a different package cannot see protected. Only the subclasses can. And in a single file demo, all classes end up in a same package. So like we'll see one show what compiles here, and the two basically points out lines that would fail if the class lived in a different package. Let's look at an example to get a better uh, understanding of these private, protected, package, private. Uh, so again, same class, person class. This is a parent with three different access levels. And we have private, which is only person can touch this field directly. We have protected, visible to subclasses and same package classes. Age, which is this is a package private, which is a default, visible in same package only. And public, person, initialize all three fields in we have three fields initialized. And we have public string get name. It's a public gateway to read name safely. And we have a subclass of person. This is a subclass. And what else? And public employee. Here this is constructor chaining. And here this basically prints which members it can access. We have name, ID, and name is basically name, which is commented here because it won't compile because it's private. And ID, it's protected, is visible in the subclass. And age, because it's okay here, because we are in the same package, which is a single file demo. And we have get name, this is also okay here because it's public getter. Public getter is the right way to read private data. And we have another class here, which is not a subclass of person. And the void, public void peak is, it checks what an unrelated class sees. P dot name, it's commented out because it's private, not visible. p.id, it's commented with a note again here. It in the same package it compiles, but in a different package it would fail because unrelated is not a subclass, and protected across packages is for subclasses only. And p.age, it's okay here. It's the same package. It would fail from another package, but yeah. And we have main, which is an entry point, and employee e, this builds an employee, and e dot show what I see. It's a demo subclass, visibility, again visibility rules, and unrelated u, this this is an unrelated class, visibility rules. So what to basically notice here is keep important fields private, expose them with methods that design works in all packages and avoids subtle visibility traps. Uh, Protected is primarily for subclasses. Package private is strictly for same package. If you moved unrelated to different package, the line accessing p.id would fail, not which is a not it's not a subclass, and the line accessing p.age would fail because it's not in the same package. So uh, overloading happens only in the same class. Overriding happens in a subclass with the same signature. Constructors are not inherited. Use super keyword to build the parent part first, and prefer private fields plus public getter and setters, and also use protected, uh, and only when a real subclass needs it. And arrays is fixed size. ArrayList is flexible and plays nicely with generics. That's about first slide. Next topic is overriding member methods. So overriding means a child class replaces a method it inherits from its parent with a method that has the same name and the same parameter list and a compatible return type. So at runtime, Java chooses the method based on the actual object type, not the reference type. That's dynamic dispatch, which is basically polymorphism. And we have override. So you can use it every time the compiler checks that you are really overriding, not accidentally overloading or misspelling. If you mess up the signature, you'll get the compiler error immediately. We have access and exception rules. You cannot make the overriding method more restrictive than the parent. Like example, parent is public and the child cannot be protected or private. So for checked exceptions, an override may declare no exceptions or narrower exceptions, which is a subtype exceptions. Then the parent, it cannot add a broader new checked exception that the parent didn't declare. So when to override, toString equals hashCode. So toString, it's given, it gives it's super helpful for logs and debugging, and equals, you equals and hashCode, you override together when objects should be considered equal by value and identity. For example, same employee ID. If two objects are equal, they must have the same hash code. This matters for hash set, hash map. Let's look into an example. Here we have custom exceptions. Class pay exception extends exception. It's a checked exception based for pay problems because it's checked and callers must handle or declare it. And we have class pay data exception extends pay extension, which is a narrower checked exception, which is a subtype. Subclasses can throw this while still obeying the parent's method signature. And we have person, which is a base class. Here fields are private and final for immutability for after construction. We have public public getters provide read access which are marked final, so overrides can't alter base semantics for identity fields. And here we also have employee field, which is an abstract parent. Abstract class employee extends person. We can't instantiate employee directly, so it's a common parent for specific employees types. And we have public abstract double calculatePay throws pay exception, which declares a checked exception in the parent. Subclasses must either throw no checked exception or throw a narrower one like the pay data exception, but not a brand new broader one like IO exception. And override public string toString. It's a friendly informative string that includes the real subclass name using the get class dot get simple name, which is commented here, but yeah, plus the key fields, which is name, ID. This is where toString shines. It logs and debug prints become readable. And we have equals object and hash code based on employee ID. So two different objects that represent the same employee are considered equal. We first handle this this is equal to other, which is the same reference, and then we check instance of employee. We want equality across subclasses by ID, and then for hash code we hash ID, so the contract holds, like equal objects go to equal hashes. And next we have salaried employee, which has annual salary, and will override the calculate pay, which returns annual salary, uh, which is divided by 12. You'll notice that there are no throw clause here. uh, that's legal because it's fewer checked exceptions than the parent, which is basically 0 versus pay exception. And again, override toString adds annual salary while reusing the super dot toString. And next we have hourly employee, which has hourly rate and hours for this month. Again, override which you override the calculate pay, uh, which throws pay data exception, which declares a narrower exception than the parent. uh, Pay data exception is a subtype of pay exception. It validates inputs and throws a checked exception on bad data. Otherwise, returns where is it? Returns hourly rate multiplied by hours for this month. Um, and again, override toString, which basically adds its specific fields. And then we have main. Here we create two employee references pointing to different subclasses. Sally, which is a salaried employee. Hank is a hourly employee. Uh, and then we try catch. So Sally dot calculate pay calls the salaried employee version, and Hank dot calculate pay calls the hourly employee version. Even though the variable type is employee, Java chooses the method by the actual object at runtime. Um, what else? Yeah, system dot out dot println Sally. Hank automatically calls the overridden toString, uh, producing a clean, readable lines. Uh, Next we have equals and hashCode in the hash set. So here we add Sally and Hank to a set. We then add Hank duplicate with same ID but a different subtype, because our equals compares IDs and hashCode matches, and the set keeps size 2, proving the contract works. And we also have exception rules in practice, like bad hours has negative 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 hours, and uh, calling calculate pay throws pay data exception, which is a checked exception. We catch it as the parent type pay exception, which is normal in Java. uh, Basically you catch the super type to handle all narrower types. And So here uh, calculate pay has the same signature across the hierarchy. Java picks the right one at runtime, which is dynamic dispatch. We override everywhere. We mark each override so the compiler verifies it. And also here access is more restrictive. Parent method are public, but child overrides are also public. If we made a child override protected or private, it would fail to compile. We have checked exceptions. Parent declares throw pay exception. Salaried version throws none, which is allowed. Uh, and hourly version throws pay data exception, which is narrower. This is also allowed. If the child tried to add a uh, new broader checked exception, like an example is IO exception, it would not compile. And here we also discussed about toString equals hashCode. We overrode all three where they add real value, human readable objects, and correct behavior in hash collections. So here overriding is where polymorphism lives. You write code that talks to the parent type, and it does the right thing for each child at runtime. And override saves you from subtle bugs. Use it every time you mean to override, and understand access and exception rules now, so they stop confusing compiler errors later. Uh, Good toString equals hashCode make your program easier to debug and your collections behave correctly.